Hello everybody and welcome back. I'm trying to create a little bit of documentation regarding some of the developments with the Robin printers, and I thought I'd turn the camera on. What I've been trying to do was I've been trying to get this printer to go as fast as it is possible for the components, without losing steps or without destroying itself. And I've been at both points where it was losing steps and where it basically destroyed itself, and I'm creating new parts just to make this one as fast as it could go. The first thing that I did was I started printing these 4x4 cubes as quickly as I could. And this is basically the last one where I got it to go as fast as it would go. And I mean, like, really fast. I have acceleration set to 6,000 and I have the value for jerk set to 40. So it will start every move where it needs to go further than like half a millimeter by just pulling the carriage half a millimeter and then starting acceleration. It sounds awful. It sounds like the printer is going to go at any minute, but it doesn't. I did find a few shortcomings along the way. This is one of the earlier printers that I built, and some of the parts that I had, like this X-axis carriage holder, they look perfect, and they did hold out very well, but they did deform just a little bit over the past 1 year. And what I hadn't expected is the filament or the part has gone soft. It is very easy to bend, and I didn't expect this. So this is PLA Plus. It's a very hard and very light material, but I didn't expect it to go soft over time. So it is really easy to bend this over. And for a 3D printer, this means vibration and this means ringing. And it also means that over a long time, this is going to deform. And once it deforms, I'm going to have problems keeping the belts on the rails. And that's what I'm working on right now. I've created new parts. This one already has them, but I'm going to do some more. And I'm going to add this into this video. And my next take is to use acrylic parts, 2 layers, glue them together to give them more rigidity and a little bit of dampening if they do start to ring, because they're back to back. And I did this for the X-axis carriage because I removed this one, and I'm going to do it for the idler too, and the idler is going to be more solid than it was before. Regarding weight, this doesn't make too much of a difference because that is not a moving part. I did go ahead and I reprinted the X-axis extruder holders with less infill. So I reduced the mass on the X-axis, but these parts were already made for weight, for performance. The entire holder parts are only 25 grams, and that adds the V6 extruder and the one single fan and the height probe. That's it. There are no more parts on this, and this thing can go insanely fast. And the last thing that I changed was I changed the belt that I had on it for one that is rated for a higher load. I don't see that it ever can reach that load, because you'd be starting to pull off the teeth before exceeding the load that the belt material is supposed to withstand. And I just did this so I had less ringing. And although I did pick up quite a large amount of Z-axis wobble, because I moved the Z-axis twice and it's not mounted correctly to the stepper, the amount of ringing that I have is not as bad as I would have thought. There is some in the edges, well, because it is actually doing 2 jerk moves with 40 steps each, so it's more than, it's basically exactly half a millimeter, and you can see this in the ringing around the edges. But it still produces a pretty respectable surface, and it is now capable of actually reaching 100 millimeters per second on a 40 millimeter run. So the main problem that you have is, and that's the reason why most of the time estimates for your print are so far out. Most of the time on printing a surface is spent in accelerating and decelerating. So if I have acceleration set to 1000, it will accelerate over 1/3 of the length. It will then go at the set speed, and it will take another third for decelerating. Since the Repetier firmware uses a modified ramp, it has a real acceleration value, you get good acceleration, but well, we can still accelerate faster, especially when we have a printer like the Robin, where all the parts are very light. The x-axis is meant to be light. The y-axis and the table, this Metawell material, is also very light, and the pulleys and the stepper constructions are made to not vibrate. So I think I can still go faster, so I could probably accelerate faster than 6000, and I may have to reduce the jerk value down to something like 32 or 30, just to make sure that I'm not actually jumping beyond a step. So yeah, that's what I'm going to do now. I'm going to make these parts, and I'm going to add these parts to the 3D printer then, and let's see if we can go still faster. So here are the parts. That's the original, and this here is the new X-axis mount with the stepper mount and where the linear rail goes. As you can see, I shortened it by 15 millimeters. The original design was to have the stepper further outward to basically balance the weight of the rail better. This is still valid, but since I want to go as fast as possible, it actually just it just works toward vibration. And if I can make that shorter, I'm going to have less vibration, a higher frequency, and less of an amplitude. And so this is now 2 parts. I've even made it stronger, and they're glued together with a soft glue. So if I do get some ringing inside the material, because this still bends a little, I have some dampening in between here. I've tried this before. It works really well. And the idler, before the idler was always 1 part, and now the idler is going to be 2 parts, also glued together, just to give this a little bit more stability. And yeah, I'm going to try to mount these now, and then I'm going to do another speed test with the little cube. I hope this works. I've been having tons of problems with adhesion just because my basement is so cold in winter, and at I don't know, below 20 degrees the filament just won't stick to the blue tape, and there's very little I can do. I can heat up the basement room, but that takes a lot of energy, or I can just try and heat up the print bed a little bit with a fan and then go from there. So yeah, let's try to get this mounted. It's really easy to take apart. I still like the design very much. It is so easy to service. Since I do take these to the classes that I'm giving and to all the maker fairs and meetings, they do accumulate a lot of working hours, but they just don't care. I've only had 1 failure so far, and that was due to human error. I just didn't think what I was trying to do through to the end, and well, I broke some parts. So that is the idler that I have been using so far. It does have the advantage of having this block here, which slides into place on the rail, and it just gives a little bit of extra stability towards the screws that are in at the back. And for going slow and for having a very simple build, that is still the way to go. I'm not changing anything. So this year's just experimentation that I'm doing right now. But these larger parts will be a lot more resilient to vibration, and I can pull on them a lot more than I could with the 3D printed parts. And I can't get this foil off. Yeah, enjoy this. There's one. There's the other. I'm gonna have to go grab some glue to glue these together before I mount them. Yeah, I could just stack them and screw them in, that would work too, but I really want to have the glue in between there, just because it makes it become more of one part on the one hand, and it actually works to dampen vibrations that you get between the two. I've been trying a couple of different glues. I tried cyan acrylate, and that works for gluing these, but I went to the more standard old style glue that is just that stays soft for a lot longer, and that works really well. So let's get these on here. I'm going to have to go grab some longer screws for all the parts, because I've just doubled the thickness of the part. I hope I don't have to go out and buy anything because everything's closed. We're on lockdown. Let's hope. I think I just jinxed the whole project by saying I might not have all the parts that I need, because that's exactly what it looks like. I haven't even started and I'm already short on M5 screws in the correct length, and it's looking bad for M3s as well. Oh well, let's just soldier on and see if we can get everything together that we need. This is not going well. Oh, this might just work out. Yeah, just about. And do we have any more of those? Yeah, we do. So, going fast with a 3D printer is one of the hardest things. If you go slow, it's really easy to get quality, and if you don't have any play in any of your parts, then you're safe. But if you want to go fast, then every little thing that's wrong with your 3D printer is just going to show up. And it's going to do so at the most inopportune time. Well, let's just tighten this down lightly. See if these will work. Yeah, they're long enough. So they're actually too long, but still better than too short. We need a washer, and we need 2 bearings, and the washer should be on the other way around, so the bearing turns. Yeah, that's gonna work. Now we have 1 steel M5. It's gonna be good too. We'll need another washer. And yeah, no washer at the top, because we just clamp down with all the force we can muster, and there will be 1 small washer and 1 large washer at the bottom to make sure that the belt doesn't fall off, which we don't need if everything goes well, because that is just a precaution. And something is different because the belt is now shorter than it should be. Did I make this part too short? Yep, I did. I'm gonna have to fix this, but not with this part. I'm gonna try it out first. But I'm not gonna have full length. Oh. That means that probing won't work, I bet. Just gonna try it like this now. Well, it looks like a good part, and but it's actually making it. I basically lose like 10 millimeters of x-axis, and that's not good. So those are the wrong parts. Yeah, need to get that fixed. I bet they're for the larger implementation of the robin, for the big robin, and I just picked the wrong parts when I put them on the laser. Not sure what I'm gonna do now. I'll bring you back once I figured it out. So let's give this a try. I'm not sure that this is going to work fine. I wonder if I can configure auto leveling to off. Yeah, it's off. That's probably part of the G code. So it's going to run into one or the other end. I think should be fine. And leveling might not be okay, and I'm going to do this manually by just twisting the threaded rod. I'm trying to get this to be somewhat correct. I've already checked that the belt won't fall off. This is usually very good when I'm using the acrylic parts because they don't flex at all, or very little. So now this is now set to acceleration of 6,000 per axis, and it's got a jerk value of 40. So the jerk value is basically the start value for acceleration. This is the change of positions that it can go without going through acceleration. And 40 is about the absolute maximum that I can go without losing steps or breaking stuff. Yeah, I did have the problem that the 3D printer kept moving on the table. So that's auto leveling. I did speed that up a little. I can go down on that setting. It might not be as perfect as it was before. So are we getting anything here? This is not going well. we go. So this is the first layer speed. It is slightly reduced. But it's really gonna gun it later on. So the first layer is not going to be good because I didn't have the leveling set correctly, but I don't see a lot of vibration on the x-axis because there might be a little bit of slack in the rail. But when it's doing the very quick to and back, I can see a little bit of movement right in the back of here. That's due to the drag that the y-axis is putting on the extruder. That seems to work okay. We haven't lost any steps yet, and the reason why it's not on the position where it was before, that is because we ran into the end of the 3D printer during leveling. So if you wanted to go faster, there would be no other way of doing it but by adding a second post on the back of the 3D printer, just to make sure that the x-axis can't move front to back. So as you can see, we're picking up a little speed. It's doing a little bit of needle skipping over some of the imperfections that were on the first layer. That should go away after a couple of layers. I don't care for that right now. I just want to see if we lose steps and how far it will go, especially when it's doing the infill. So I think the maximum speed that I'm going between printing, like just positioning, is 180 or 200 millimeters per second. That's really quick, but it won't reach that speed because it's still going through acceleration and deceleration too. It just looks really, really quick. Now, I'm doing all of these experiments because I want to get back to working on the Big Bad Robin, which is a lot bigger than this one, and I want to change the Big Bad Robin to also just have the simple extruder. Although it is going to have a different hot end, I'm going to go for 0.6 millimeters. And I'm going to use a volcano hot end. So yeah, that's still a solid layer. I think we're up to 4 layers at the bottom, and it's going to go for, yeah, it's 4 solid layers, and then it's going to go for the infill. But it did pick up speed. No, what I was saying is I want to do the Big Bad Robin, and I want to build the Big Bad Robin with a hot end holder like this and a Bowden extruder. And once I'm done doing this, I want to be able to fine-tune this because the Big Bad Robin has just a simple crane like this one, and I want to find out how fast I can go and how much tension I can put on the belt and pulley. And once I have that figured out, I can then go look for different parts or maybe even a different setup. I was thinking of maybe not having a fan at the top at all, but blowing compressed air through a tube onto the print and using compressed air to cool the extruder. Since I do have the leftover air pump from my laser, so yeah, that is really quickly now. But we're still getting a little bit of surface scratching. Yeah, and what you can see now is these jumps in the position. I don't even know if they're going to come over on YouTube because it reduces the frame rate so much. But you can really see how it skips between the different jerk moves without positioning at all. It just goes there. Yeah, those are nice moves. And since it's now not hitting the filament at all, I don't have any movement in the x-axis anymore. So that was what I was looking for. And I'm also not losing the belt over the pulley, so they're nice and square to the surface of the acrylic. And yeah, that makes for fast moves. So what I need to do is I actually need to move these pulleys out, like I would say about, I don't know, 6 millimeters or so, and just make this part longer. And once I have that, I can put this on this printer, and I can use this one for the Big Bad Robin because I don't want to go all the way to the end on that one, because that one has, I think it's a 450 millimeter x-axis and y-axis rail, and I can spare a few millimeters on those. So yeah, but it's moving nicely. It really is. Yeah, so in my opinion, the faster you go with your printer, the more it's going to expose all the weaknesses. And but printing fast is sometimes you need something. Sometimes you need parts really quickly, and then you want to be able to go fast. And since you can modify all the settings for acceleration and jerk in your G code, there's no reason for making the printer itself slow on purpose if it can go fast. And well, I'm just trying to find the limits here. But yeah, that's quite a mover. So I'll bring you back once it's done. I stopped the print a little bit early so we can have a look at the infill and see how well it's doing that. And it's kind of hard to see, but the infill is just, well, it's still good. It could be better, but we can see that it's actually going right up to the corners of the print. There's a little bit of tearing inside, but that's partially due to the fact that we're going so fast. So the infill speed right now is 160 millimeters per second. The outside speed should be around 140 to 150 millimeters per second, and this is just a 0.3 millimeter nozzle, so there is a lot of pressure on the filament, and I guess there are just some limits to what you can get through this small nozzle, even with the geared extruder that I'm using. So this printer has a TiVo Titan extruder, and that one delivers a lot of pressure, and I'm pretty happy with that. But yeah, it seems to be just on the border of what still works. And we can see that we do not have any problems in the edges towards the outline of the print, which means that it's working pretty well regarding the jerk movement. It appears to be able to keep up the pressure in those areas. But yeah, this looks pretty nice. What you can see is we do have some ringing in the edges here. It's going around counterclockwise, and we do get a pretty sharp edge on all the edges, and there is some lead out ringing in there. But I mean, we're going max speed. This is pretty bearable. I've seen a lot worse going a lot slower. Yeah, so that is basically the maximum speed that I can go. That is 160 infill, 140 to 150 on the outside. But I might not be seeing the whole speed because I still have acceleration in there. I could probably go up with the acceleration to, I don't know, 6,500 to 7,000, but I'd really be pressing my luck on that. And basically, that should just make these little ringing formations longer. It shouldn't make them worse, because the really bad spike that we're getting at the end here is where we're returning from the jerk movement. And with the changed parts, so with the acrylic idler and the acrylic motor mount, that has reduced that quite a bit. What I'm really happy with is that we are not getting a huge spike at the point where the z-axis is settling, the y-axis, because the y-axis is moving the table. It does have a little bit of distortion in here. Let's zoom into this a little more. That's the wrong way. Let's try and get this into focus. We do have some pronounced ringing here, but we also have some distortion in the z direction, which means that the table is actually vibrating when it's stopping, and like the 40 jerk is the absolute maximum that I can go before this gets really bad, but the surface still looks well enough. So I feel like I am going to leave the firmware the way it is, and I will maybe try to use slicers where I can set the acceleration, where I can just lower these values just a tiny bit. So I may just lower the jerk value a little bit, but for having a sample with absolute maximum speed still coming out like this, I think I'm going to not change that much. And I'm going to use the experience that I've gotten in dealing with these speeds when I start modifying the larger printer. And I think that should get me somewhere. Also, what I may need to do is I may need to get some silicone feet or something for the printer, because at these speeds it's actually moving across the table, and it's one of the big pros of this printer is the heavy aluminium frame that just gives it so much rigidity and it makes it so sturdy. But with these accelerations right here, this thing is just moving across the table. Yeah. So, well, yeah, that was a nice experiment for speed. I think we've pretty much maxed out what this printer is able to do, but it seems nice enough. I did do some other test prints at this speed, and what I liked a lot was this little apple jar. It came out pretty much perfect, and even the overhangs were very nice. Just because it's going so fast, it can really string overheads very nicely. What you can't see on this sample here is that I picked up some z-axis wobble and z-axis compression because I was messing around with the z-axis and I didn't get it dialed in correctly. Also, this z-axis rod has a very evil bend to it, and I need to, I don't know, maybe I'm gonna machine the end of it down so I can just get that out of there and I can grab it with another coupler. So yeah, it really can go excitingly fast, but like I said, 160 to 180 millimeters per second extruding at 0.3 millimeters is the absolute maximum that I can go, which is saying something. And well, at least during this print, the printer didn't disassemble itself. So when I finalize these changes, when I have all the parts at the sizes that I want to have them, I'm going to apply Loctite to a lot of these screws again and tighten them down really well, so we can make sure that it's not going to disassemble itself if I ever set it to maximum speed. But seems that this one here is ready for ludicrous speed at some time. So thanks for watching, and bye-bye.